Hello everyone, myself Subrata Saha, Assistant Professor of Dr. Sudhir Chandra Sood Degree Engineering College in Automobile Engineering. So today I am going to discuss about the topic of exhaust gas recirculation or EGR. Exhaust gas means the gas is emits from the engine after the burning of air fuel mixture. Okay, so we are using the exhaust gases, a certain not 100% but a portion of exhaust gases we are using. So what are the basic fundamental of this exhaust gas recirculation process? We know that in previous classes I discussed about the relation between the temperature and temperature with the different kind of pollutant generation. And with the increasing temperature, the hydrocarbon and carbon monoxide will be reduced, and if we increase the exhaust gases temperature, that means NOx emission will increased significantly. So we have to put our exhaust gas temperature in a certain limit, okay, not exceed too much or not lean too much. So we have to think this matter that we have to put a significant temperature so that not so amount of NOx is generated or not so amount of CO and hydrocarbon is generated. So our main motto is to drop the peak combustion temperature. If you can remember the entropy and temperature diagram, that is the T means after combustion, that is T3 will be the maximum in TS diagram, not PB, in TS diagram. So that maximum temperature is the peak combustion temperature. That peak combustion temperature has to be reduced, and if we reduce this peak combustion temperature, we can control the NOx emissions significantly. So what are the processes we can reduce the peak combustion temperature? The process is we are using some gases inside the cylinder so that the volume, it occupies volume but not takes place in combustion, because exhaust gases have already burned gas. There is nothing burning property inside the exhaust gases. So this is very one more thing, it is very easily to available. So that's why exhaust gases are used widely in automobile that can use. But instead of exhaust gas, if we use some inert gases, the result will be same. But what are the problems? Problems is basically the exhaust, inert gases are, you have to purchase that inert gases that is not generated in the engine or not generated in a vehicle, any other component in the vehicle. You have to purchase that inert gases which have to be supplied in the engine cylinder. And one more thing, that is you have to refill this inert gases after a certain portion or certain period of time or certain period of kilometer traveling of the vehicle or going of the vehicle. So this is a problem, or problem number one. And the another problem is this, you have to carry an extra separate chamber and refill in some fueling station or something other that, and from a shop also. Then you can refill by your own or by a mechanic. So there are also some costing issues, and you have to carry another tank or chamber, okay, to fill that inert gases. So that is also very disadvantage or demerits of that inert gases. That can why we are paying extra, because exhaust gases are easily to available, okay. So we are using this exhaust, we are sending this exhaust gases by an intercooler, because exhaust gas has a high temperature near about 200 degrees centigrade, okay. So from that intercooler, or the exhaust gases are coming back to the engine cylinder or engine intake system, okay. So this portion, certain portion of the exhaust gases are going to the inlet manifold, and this is the EGR valves, okay. So this is the basic fundamental diagram or basic diagram of an EGR system or working principle, okay. So here is you can see there is a valve. This is the main thing of an EGR, that is called the EGR valve, which is basically an poppet type spring loaded vacuum operated valve, okay. We will coming on later on this topic, EGR valves. Now, what is EGR valve? EGR valve is basically introduced in 1972, and as I told earlier, that it controls spring loaded vacuum operated and poppet type valve, okay. And it controls the amount of gas which is entered to the inlet manifold, okay. So what amount of exhaust gas are what amount of exhaust gas which are sending or sent to the inlet manifold. That is the main motto of the EGR valves, or main purpose of the EGR valves. EGR valve is also it can installed in either intake manifold or in between the carburetor and intake manifolds also, okay. So in this process you can install this EGR valve, okay. This is the real picture of a EGR valve. You must see in a BS4 vehicle. If there is any EGR system is available, in BS6 EGR is must, EGR and SCR both are must. So this is the valve, EGR valve. This is diaphragms, this is the spring loaded valve, and this is the vacuum side. This is and this is the diaphragm. Here you can see the diaphragm, okay. And this portion is open to exhaust, and this portion is open to intake manifold. So these are the diagram of the exhaust gas recirculation valve, and this is the process. Once again I am telling you, this is the process. This is the exhaust gas which is coming to the engine's intake cylinder by opening the EGR valves, and this EGR valve is controlled by the ECU and some different kind of sensors, okay. And it is totally vacuum operated and spring loaded and also poppet type valve. So these are the easier valves. Now coming to the next slide, easier valves mounted on the intake manifold. As I told you earlier, that is two types installed either in intake manifold or in between carburetor or intake manifold. So it is on the intake manifold. You can see this is in left side. You can see the metering valve. This is the easier valves, and then after easier valves you can see the air intake system also. Okay, so it is installed. This easier valve is mounted on the intake manifold. This is mounted on intake manifold. Now this easier valve is mounted after the carburetor. This is the easier valve and this is carburetor space, and this easier valve is installed. At first easier valve carburetor, then the easier valve is installed. Okay. Now easier system. Easier system is also classified into two types. One is ported vacuum system, another is Venturi vacuum system. Okay, so the easier system can be classified as a two type. One is ported vacuum type system, another is Venturi vacuum type system. This is the diagram of the ported Venturi type system. Here you can see the easier valve is set on this, and this is the exhaust lining, and this is the carburetor. In left side you can see the carburetor in inlet manifold, and due to this inlet vacuum, the creation of this vacuum, this easier valve is open and the exhaust gases are enter to the intake manifold. Okay, so this is the type of ported vacuum system. Now this is the Venturi vacuum system. Venturi vacuum system. You can see here there are the carburetor, and this is the intake, and there is easier or exhaust gas easier valve or exhaust gas recirculation valves, and in between carburetor and easier there is also amplifier. What is amplifier? Why amplifier is used here? Because it used because the amplifier can amplify and also it can helps to open the easier valve, because mainly this amplifier is controlling the easier valves open and close. Okay, so this easier valve can be operated in the in this type by the amplifier. Okay, so these are the type. So what are the types are the ported vacuum system and Venturi vacuum system. These are the two types of easier valves, and one another type of easier, this is the easier systems, and one another type of easier valve, there is a dual, here you can see here is a single diaphragm easier valve. So another type of easier valve is the dual diaphragm. That kind of valve can use the dual diaphragm or two diaphragms. So this is the diagram of ported vacuum system. Ported vacuum means this intake portion is this manifold, this intake manifold and the carburetor, there create some vacuum. Okay, and an opening of the throttle plate can expose the port to the manifold vacuum, and the exhaust gas flows depends on the manifold vacuums and throttle positions, and also exhaust gas back pressure also. Okay, so what amount of back pressure is needed, that is also important. And as ported vacuum that can add at the maximum to be equal in the inside intake manifolds vacuum, and recirculation at wide open throttle is prevented also, and the valve opens at the point that greater than the relatively weak manifold vacuums that produced during the wide open of throttle operation. Okay, and in Venturi vacuum system, this control, the vacuum control is not so important, and vacuum control is very less efficient in that case. So amplifier, as I told you earlier, the amplifier used to boost to operate the easier valves, and all through the exhaust gas flows depends mainly on the engine intake flows also. Okay, and it is also affected by the intake vacuum and exhaust back pressure also. And a relief valve or dump diaphragm compares Venturi and manifold vacuum prevents recirculation of the exhaust gas at the wide open throttle, and when the diaphragm senses the throttle at the wide open, the stored vacuum in the amplifier is released to the atmosphere, and this prevents the manifold vacuums to reach the easier valves also. And since the easier valve opens at the midpoint, and that is greater than the relatively weak manifold vacuums, and the valves remains closed at the wide open of the throttle. Okay, so these are the process of Venturi vacuum system, and these are the valve locations. As I told you earlier, these two locations, one is easier valve mounted on intake manifolds, and on the and this type of easier valves in some cases used by the external steel tubing pipe also. Okay, and spring holds that the easier valves. Main component is a spring. That spring holds the easier valves in the closed position, and the valve is opened by the port or Venturi vacuum from the carburetors. Okay, and small amount, the temperature below 1645 degree Kelvin, below that temperature the NOx emission is very very low. So we have to control this combustion process in between 1645 Kelvin. It is the crucial temperature point for the NOx generation. So we are sending that exhaust gases again into the intake manifold, so that we are using using such amount of volume which cannot be take places in the combustion. So what will happen? The efficiency will be dropped, and peak combustion temperature is also dropped. So a easier setup engine is always performing low than the non-easier type of engines. Okay, so this is the today's topic. This is exhaust gas recirculation. Okay, thank you.